Good afternoon, classmate. Our topic is all about the Friedman Test. What is a Friedman test? It is a test developed by Milton Friedman. It is a non-parametric statistical or hypothesis test to compare the differences between three or more dependent groups. It is also similar to the Kruskal-Wallis test, and it is an alternative to the one-way ANOVA with repeated measures. Wait, let me explain. If you can see, nagawa po ako ng table para mas maintindihan nyo. Nakikita nyo dyan yung ANOVA, Kruskal-Wallis test, and Friedman test. Diba sabi po kanina, ang meaning ng Friedman test is similar to Kruskal-Wallis test. If you can see, same ang Kruskal-Wallis and Friedman test na non-parametric, which means yung distribution of data nila is abnormal. Regarding naman sa group, same naman po sila, 3 or more. Nag-differs lang sila because ang Kruskal-Wallis test, independent group. Friedman test is a dependent group. If you can remember from our previous topic na Kruskal-Wallis test, inexplain po ni Doc regarding yun sa ANOVA, Kruskal-Wallis test. And di ba po ang Kruskal-Wallis test ay may limitation because independent group lang po yung tinetest niya. Ang meaning po, ang independent group ay example. Gusto mong i-compare yung mga scores ng first year student from section 1, section 2, section 3, and section 4. So which means it's independent kasi you will be getting the scores from different sections. And ang example naman po ng dependent group, before when we were high school, we have first periodical test, second periodical test, third periodical test, and fourth periodical test. If you want to compare the performance of the students from first, second, third, and fourth periodical test from first year high school student, that is an example of dependent group. Balikan po natin yung meaning ng Friedman test. Sabi po doon, it is alternative to ANOVA test. So if you can see in the table, ang nag-differ sila sa distribution and parametric test kasi ang ANOVA is a parametric with normally distributed data, but the Friedman test, that is a non-parametric and abnormally distributed data. But same sila ng tinetest na 3 or more dependent group. So ito yung tinutukoy ni Doc last topic natin from the Kruskal-Wallis test na 'di ba may limitation ng Kruskal-Wallis test. It just tests the independent group. And yung Friedman test ang nagtetest for dependent group. Comparing naman po for the computation, ang ANOVA, you will get the mean. For the Kruskal-Wallis test, you will rank the data by column. And for Friedman test naman, you will rank it by row. You will see it later sa computation ng Friedman test. When do we use Friedman test? You want to know if many groups are different on your variable of interest. Difference means you are looking for a statistical test to see whether 3 or more groups are significantly different on your variable of interest. Example, patient serum content monitoring before treatment, after 1 month, and after 3 months of treatment. Your variable of interest is continuous. Continuous data. Continuous means that your variable of interest can basically take on any value such as heart rate, height, weight, number of ice cream bars you can eat in 1 minute, 5 minutes, or 10 minutes. You have 3 or more groups. 3 or more groups can be used to compare 3 or more related groups on your variable of interest. You have related samples. Related samples means that you have repeated measures from the same units of observation. Example, if you have a group of men undergoing a treatment and you measure their cholesterol levels at 3 times, 1 week, 2 weeks, and 3 weeks, then you have 3 groups of related data. This test is best statistic to use for a repeated measures type of experiment across multiple tests to determine if a particular factor also has an effect. Now we're on our next part, so I will be providing you examples so we can see how to compute the Friedman test. Question. We are testing the miracle pain reliever drug at dose of 10 mg and 20 mg compared with placebo in patients suffering from headache. 6 patients were given each of the treatment for 1 day with washout periods between each treatments. Pain were obtained for each patient in the 3 groups 1 hour after administering of drug or placebo. The pain score are listed with the level of significance of 5%. So this is our data. We have 6 patients and 3 groups. This is similar to Kruskal-Wallis as I have mentioned earlier, except we have the same participant in each group. So we have group 1 for the placebo effect, group 2 for 10 milligrams, and group 3 for 20 milligrams. Now let's state our null hypothesis. There is no significant difference in the pain scores of the patients between the 3 treatment groups, or mu1 is equal to mu2 is equal to mu3. And the alternative hypothesis is there is a significant difference in the pain scores of the patients between the 3 treatment groups, or mu1 is not equal to mu2, not equal to mu3. For the level of significance, 5% or 0.05 for the tail, 1 tail test. For the test statistic, of course, Friedman test. The degree of freedom, number of groups, which is 3 minus 1 is equal to 2. And for the critical value, I will show you the chart. If you can see here, critical values of chi-square, Kruskal-Wallis is same as Friedman test. So we will find the degree of freedom of 2 and 0.05, which is 5.991. This is the summary for us to see and review. So this is our area of rejection and acceptance with a critical value of 5.99. So this is our formula. FR is equal to 12, that is a constant number, over NK, open parenthesis, K plus 1, constant number, close parenthesis, summation of R squared minus 3N, a constant number, open parenthesis, K plus 1, close parenthesis. Where N is the number of columns or participants, K is the number of row or treatment level, R is the total rank per column. So let's go back to our data. So the number of participant is 6 and the number of group is 3. So we need to find the total rank per column. I made a table for us to understand more. We will be ranking it by row. So I placed a rank at the side of every group. We have 3 groups, so we should rank it to first, second, and third, where the lowest pain score ranks first and the highest pain score ranks third. Again, we will rank it by row because the patient is receiving all the 3 treatments. So the first patient have a pain score of 10 with the placebo, 7 getting the 10 milligram, and 3 receiving the 20 milligrams. So 3 is the lowest pain score. It would get the rank 1. 7 is the middle pain score. it will be getting the rank of 2, and 10 is the highest pain score, so it will get a rank of 3. If there is a tie, see the patient 6, meaning they have the same pain score. Then between two of the treatments, we will be splitting the rank. So we get rank 1.5 for 10 mg and 20 mg. And for the placebo with pain score of 6, it will be rank 3. After ranking all the patients' pain scale, next we need to rank it by column. So group 1, which is placebo, have a total rank of 18. Next is group 2, which is 10 mg, have a total rank of 9.5. And group 3, which is 20 mg, have a total rank of 8.5. We already have all the data that we need, so we go to the next part, which is the computation. So this is our formula. Then we substitute. So 12 is a constant number over nk. So n is the participant, which is 6. Then k is the number of groups, so 3. Open parenthesis k, which is 3 plus 1 is equal to 4. Close parenthesis times summation of the total rank. So first is the 18, then squared, plus 9.5 squared, then plus 8.5 squared, then close parenthesis minus 3. That is a constant number again, and n is 6. And open parenthesis k plus 1 is equals to 4. So the total, or the answer, is 9.08. Now we should locate whether the result is on the area of acceptance or rejection. So our critical value is 5.99 and the result is 9.08. So if you can see, it is on the area of rejection. Now we're on our last part, so the decision is reject the null hypothesis. If we will be rejecting the null hypothesis, we will be accepting the alternative hypothesis, which is there is a significant difference in the pain scores of the patients between the 3 treatment groups. So the analysis is, since the computed FR is 9.08 is greater than the critical value of 5.09 at 5% level of significance and the degree of freedom of 2, thus the null hypothesis is rejected. Therefore, there is a significant difference between the 3 treatment groups, meaning the patient's pain response depends on the dose of the medication that has been administered. And that's the end of our topic about the Friedman test. Thank you for listening and God bless.